Okay, so here we have the percentage of a piece of carbon-14 remaining in a piece of fossilized wood is given by P equals to 100 times of e to the power of negative kt. So when you see this kind of an expression where you have e to the power of negative k times the time, where the time is measured, t is the time measured in years, we know that when t is equals to 0, that is the initial, at the initial, negative k times 0 will still be 0, and e to the power of 0 is 1, which means that when time is equal to 0, we have 100 times 1, and that is the percentage. And that, of course, would make sense because we start at percentage 100. So other information that we can get is that when the time is 5730, the carbon is reduced to half the original amount. So the original amount was 100%. So half of the original amount would have to be 50%. So now we are sure we can come up with two equations, and let's see what we can find out from there on. So in part 1, when t equals to 0, we find that p is 100, e power negative k 0, which is 100, and we know that this is in percent. When t now has a value of 5730, the value of p is now half of it, so that would give us 50. And when we substitute t equals to 5730, we also get 100 e power negative k times 5730. So from the second equation, we will end up with e to the power of negative 5730 k equals to half. So now our objective is to find the value of k, which is in the power, and since the base is e, we would want to take ln of both sides. So taking ln of both sides and bringing the power down, we get negative 5730 k ln e, which we know is 1, is equals to ln of half. So now the value of k is simply ln 0.5 divided by negative 5730. So get your answer in 5SF, then round it off to 3SF. So here we have the value in 5SF, and the 3SF value for k will be 0.000. This is the first SF, second, and the third. Now they want the percentage of carbon-14, in other words, they want the value of P, which would indicate a fossil age of 8,000, means that T equals to 8,000, find out the corresponding value of K, the corresponding value of P, given that we have already found K over here. And of course, this is the most exact value that we can use instead of 0.000121 or 0.00012,097. When T is 8,000, the value of P is 100, still 100, times e to the power of negative, so the value of k is ln 0.5 negative 5730. This is my k multiplied by 8,000. So the value that we obtain will be 37.9939. So we round this off to become 38.0. So the percentage would be 38%. To indicate 8,000 years old. Now in part B, it's a separate question. Okay, now in part B, we have the size and intensity of an event is connected by this formula. So depending on the intensity of the event, the size changes, and C over here is a constant. So without actual values given to you, they want you to find the size of the event, which has intensity that is 50 times that of an event of size 2.4. So we know that here we are dealing with two separate events. The first event has a particular intensity. It has a corresponding size of 2.4. The second event has an intensity that is 50 times of the previous event, and they want you to find the corresponding size. So let us place some of this information. Let's write some of this information down first. So let the intensity of size 2.4 be intensity 2.4. For example, we can call it I1 or I2, it's up to you. So for this particular intensity, it has a size of 2.4. Plugging this into the equation, we have 2.4, which is the size, is log intensity that corresponds to the size of 2.4 divided by a constant c. So this is the first equation that we have. Now they want us to find the size of an event with 50 times the intensity of the previous divided by c. So now this size over here, we can call it, we can leave it as s actually, and that is what we want to find out. So this is my equation number 2. Our objective is to find s. So here we have two equations with, unfortunately, 3 unknowns. So we need to find a way to get rid of 2 unknowns at the same time. So if we consider subtracting one logarithm from the other logarithm, so for example, let's take equation number 2 minus equation number 1. We will end up with, on the left hand side, s minus 2.4, and on the right hand side, log 50i 2.4 over c minus log I 2.4 over the same c. So because when we are doing subtraction of logarithms, they can be combined together. So we have 50i 2.4 over c divided by I 2.4 over c, which we know that this can be replaced by multiplication, and we flip over I 2.4. Now things will start to get easier. We can divide by c on both sides, both numerator and denominator. We can likewise divide by I 2.4 in both the numerator and the denominator. So now we are left with s equals to 2.4 plus log of 50. So we get a value, round it off, because they want it to be in 1 decimal place. So after you round it off to 1 decimal place, our answer will be 4.1. Okay, now in question 9, we have a trapezium. They give us the vertices A with the full coordinates. B, we have, because it lies on the y-axis, so the x value is 0. We have an unknown P. C, we have the full coordinates, and D, we do not know what that is. So because it is a trapezium, they are parallel, so I know that the gradient of AB is equal to the gradient of DC. In addition, they give us that the angle over here is 90 degrees, so I know that gradient of AB multiplied by the gradient of AD is equals to -1. So this gradient of AB can be replaced by gradient of DC. They also tell us that angle ABO is equal to angle CBO, and because it is bisected by the y-axis, we know that the gradient of AB is going to be equal to the negative of the gradient of BC. So these are the information that we have obtained based on the introduction to the question. So express the gradients of line AB. Okay, quite easily done. Gradient of AB in terms of P, so we have P minus 1 over 0 plus 2, which gives us P minus 1 over 2. Now they want the gradient of C to B. That will give us P minus 3 over 0 minus 1, which is P minus 3 over negative 1. So we're going to make use of this relationship. They are the same gradients except for a multiple of negative 1, the mirror image about the y-axis. So making use of that, we have P minus 1 over 2 is equals to P minus 3. So instead of negative 1, I change the sign to become 1. So we can multiply throughout by 2 to give us P minus 1 equals to 2P minus 6. Rearranging gives us P equals to 6 minus 1, which is 5, shown. Next, to find the coordinates of D. Now D lies at the intersection point between AD and CD. So we can set the coordinates for D to be XD and YD. Then since we now we need to find the equation of AD as well as the equation of CD, such that when we solve them simultaneously, we will be able to find the coordinates of D. So early on, since we found that P has a value of 5, we can get the gradient. We can get a gradient of AB. We can get a gradient of CD, because it is the same as the gradient of AB. In addition, we can also find the gradient of AD. So let's get started. Gradient of AB is 5 minus 1 over 0 plus 2, which is 2. So this gradient of AB is the same as the gradient of CD because they are parallel. So this will also be 2. Now we are going to find the equation for CD, because we now have the gradient and we have one set of coordinate. So let's substitute into the equation y equals mx plus c. 3 equals to 2 times of 1 plus the y-intercept of CD. In this case, C will be 3 minus 2, which is 1. Equation of CD is y equals to 2x plus 1. So we're going to keep this in mind first. We're going to move on to find the gradient of AD. Gradient of AD is negative 1 over the gradient of AB, which is 2. And now we are going to use the set of coordinates from A as well as the gradient for AD to find the equation. So substituting, we have y equals to mx plus c1. We have a different c. So here we have c1 equals to 0. So the equation for AD is actually y equals to negative half x. And this is our equation number 2. So solving them, equation 1 and equation 2 at the same time, simultaneously, we will end up with xd equals to negative 2 over 5, and y has a value of 1 over 5. So d has coordinates negative 2 over 5 and 1 over 5. Then in part 3, to find the coordinates of the trapezium using the shoelace method. Okay, so let us put in the coordinates, negative 2 over 5, 1 over 5, and p as a value of 5. Area. So right now half, draw a vertical line. Choose any point you like, but you have to go anti-clockwise. So for example, let's start with point B, 0, 5, negative 2, 1, going anti-clockwise. So next point D, negative 2 over 5, 1 over 5, 1, 3, and we go back to where we started, 0, 5. And now we have to evaluate this. So multiply these numbers. So half, draw a big bracket, 0 multiplied by 1, don't bother writing, negative 2 and 1 over 5 plus negative 2 over 5, 3 plus 1 multiplied by 5. So this is going to subtract. Now we're going to work in the other direction. This way. Negative 2 times 5, negative 2 over 5, and 1, 1 and 1 over 5, and we're not going to bother writing 0 and 3. So when you work this out, you will get 6.8 square units. Okay, so for 10 part 1, to find the amplitude for y1 and y2. So the amplitude is given by the modulus of the coefficient of the trigo. So in this case, amplitude for y1 is 2, whereas the amplitude for y2 is, so instead of negative 1, we're going to put positive 1. We're going to modulus the negative 1. Okay, because the amplitude is a scalar. Next, the period of y1 and y2. So the period for y1 is, so since they're running in degrees, we're going to use 360 degrees divided by the coefficient of x, of y. So that will give us 360 degrees. Whereas for the period for y2 is, since this is cosine, 360 degrees again divided by the coefficient of x, which is 2, to give us 180 degrees. Now next, for the interval, solve the equation y1 equals to y2. So we're going to set them to be equal to each other. Substituting equation number 1 and equation number 2, we end up with 2 sine x plus 1 is the same as negative cosine 2x. So we see that here we have an angle of 2x, whereas this is an angle of x. We need to change them to be both angles x. So at the same time, I'm going to add cosine 2x to both sides to give it, to make it cosine 2x plus 2 sine x plus 1 equals to 0. So the expansion for cosine 2x, there are 3 variants. We're going to choose the one that allows us to have sine square. So cosine 2x is the same as 1 minus 2 sine square x plus 2 sine x plus 1, and that gives us 0. So simplifying this, we have 2 sine square x minus 2 sine x minus 2 equals to 0. Dividing throughout by 2. So sine square x minus sine x minus 1 equals to 0. So unfortunately, this quadratic equation cannot be factorized. So we're going to have to use the quadratic formula, which will result in sine x equals to negative b over here, which is b value of negative 1, plus minus square root b square, so negative 1 square, minus 4 times 1 times negative 1, over 2 times of a. So working this out, we have 1 plus 4, square root 5 over 2. They did tell us about the range. Okay, so x has an interval of between 0 to 360. Okay, so square root 5 itself, sine x over here gives us two possibilities, 1 minus square root 5 over 2, or 1 plus square root 5 over 2. Now this is a value that is greater than 1. 1 plus root 5 divided by 2, yeah, that's about 1.6. So we cannot have sine of an angle giving us a result of more than 1. So this has to be rejected, leaving us with only the answer on the left. So 1 minus root 5 divided by 2 is negative 0.618034. Okay, more decimal places is better. And this is a negative value. So using our ASTC, we know that the angle X is going to lie in the third and the fourth quadrant, Q3, Q4. Our basic angle, alpha, we take sine inverse of 0.618034, or you can take sine inverse of negative of this value. Okay, because when we take the sine inverse, we want to take sine inverse of a positive value. And this gives us a basic angle of 38.1727 degrees. Now in the third quadrant, our x value will be 180 degrees plus 38.1727 degrees. In the fourth quadrant, 360 degrees minus away the basic angle, and we end up with 218.1727, or 321.8273. So round this off to one decimal place, as is with all values in degrees. All angles in degrees, we leave them in one decimal place. And this is our final answer. So for equation number 1 and equation number 2, they intersect at 2 points only, at these two angles, within the range of 0 to 360 degrees. So next, we want to sketch the graphs of y1 and y2. So for this, we are going to have to make use of our amplitudes, our periods, and our points of intersection when we equate y1 and y2, meaning when we solve y1 and y2 simultaneously. So let's start with vertical, horizontal axis. I like to divide this into 4 equal parts, because that usually will be our, because 360 degrees is usually our period. Okay, and that is the case for our graph of y1. So let us start with y1 first. To sketch y equals to 2 sine x plus 1, we should start by sketching the graph of y equals to sine x. Then we change the amplitude to 2, and we shift the graph up by 1 unit. So the graph of sine x looks like this. So this is our value of 1. Over here, this will be our value of negative 1. So these dotted lines, they help in our sketch. Okay, so this is the graph of y equals to sine x. But because there's a period, there's an amplitude of 2, we're going to conveniently change these two values to be 2 and negative 2 respectively. So here's my graph of y equals to 2 sine x. But I still need to shift it up by 1 unit. So shifting this graph up by 1 unit, the maximum point from 2 will become 3, the minimum point from negative 2 will become -1. So instead of drawing the graph all over again, I'm going to shift my x-axis up by 1 unit. So over here, okay, so if you look at the original, this was 2 and this was -2, this 1 and -1 with a 0. I'm going to shift the graph up by 1 unit, effectively shifting the x-axis down by 1 unit. So this is my new x-axis, erasing away my old x-axis. This is now value of 3. Minimum point is now value of -1. This has a value of 1 and 2. So these are some key points that we have to show in our graph. Okay, over here, the intersection points. Okay, now time to label the graph and the axis. This is the graph of y equals to 2 sine x plus 1. So the next graph that we are drawing, y equals to negative cosine of 2x. So I'm going to use another color. The amplitude is 1. So I know that my graph is going to fall within this range. The period is 180 degrees. So I am expecting one cycle within 180 degrees. And in 360 degrees, we have 2 complete cycles. So the graph of cosine 2x has this shape. Or rather, the cosine of the shape of cosine x has this shape. So if we have negative of cosine, it is going to look like this, starting from -1, and it will move up. We're going to have to divide, because there is one full cycle between 0 and 180 degrees, we're going to have to divide this into 4 parts. So the points here, up to 45 degrees, up to value of 1, down to 0, down to 180. So this is one full cycle. We're going to continue to divide this, and up to 0, over here, down and down. So my blue graph, y equals to negative cosine of 2x. So let's look closely at these two graphs. They actually intersect at 2 points. So the points of intersection are actually our solutions to our simultaneous equations, which we found to be 218.2, 321.8. So let's see if they are found in the correct range, 218.2. So this value, 218.2 degrees. So it is greater than 180, it is less than 270. So we are confident of our graph so far. The other value, 321.8. So this is the next intersection point, 321.8 degrees, which makes sense. So now the final part 4. Find the set of values for which y1 minus y2 is greater than 0. Okay, so what exactly does this mean? It means that the y coordinate for the first curve minus away the y coordinate for the second curve is more than 0. Another way of saying this is y1 greater than y2. That is, if you subtract y2 on both sides, which means they want the region where the graph of y1 is larger than y2, meaning the red graph is higher than the blue graph. So let's find the regions where the red graph is higher than the blue graph. So I'm going to highlight it. Over here, it is higher than the blue graph until this point. That is from 0 to 218.2. Now from 218.2 up to the next intersection point of 321.8, we have y2 greater than y1. So we do not want that range. Then we continue. Once we go past 321.8, we have our y1 greater than y2 again. Therefore, the range, the required answer for part 4, this required set of value x starting from and equal to 0, okay, from 0 degrees up until we cannot include 218.2 degrees, because at 218.2 degrees they have the same y value. That's why this inequality is just smaller than, as compared to this is greater than or equal to. So this is one set. The other set of value will be x is greater than 321.8, but it is smaller than or equal to 360 degrees. Right, in question 11, we are required to find the shortest distance of P from OX. Okay, so this is our required value, as well as the shortest distance of the same P from OY. And we have to find this in terms of theta. So making use of the fact that OY is perpendicular to OX, then we have a pair of parallel lines over here. Since this angle is theta, this angle over here is also theta, by alternate angles parallel lines. So because we know that this is 4 kilometers and we have an angle theta over here, the shortest distance from P to OX is equal to the hypotenuse, and since this is theta, we're going to be using cosine of theta. Okay, all these came from, if we were to call this, let's call this h, so cosine theta is equals to the adjacent h over 4. Therefore, h is 4 cosine theta. So similarly, shortest distance from P to OY will be the same hypotenuse, but now it will be sine of theta. Okay, now in part 2, they want us to show that 20 cosine theta plus 12 sine theta is 15. They do not give any more context for this, so we have to try and figure out if the previous part in part 1 is going to be helpful to us. Okay, so let's see. Here we have 4 sine of theta, and this is 4 cosine of theta. We notice that this OXY is a right angle triangle, and we see that the right hand side has a value of 15, the left hand side has a value of 12 and a value of 20. They look like combinations of these numbers. Okay, for example, 15 is found by 3 times 5. 20 is found by 4 times 5. 12 is found by 3 times 4. So there's some multiplication going on. What comes to mind is actually area. So are we able to use these dimensions for the area? Turns out we can. If we look at the large triangle OXY, its area is found by half times 3 times 5. And this large triangle is subdivided into 2 smaller triangles, the first of which, YOP, we can use half times 3 times 4 sine theta to get the area. And similarly for the other triangle OXP, half times 5 times 4 cosine theta. So if we add these two areas up, we are supposed to get 15 over 2. So let's try that out. Area of OXY is half times 5 times 3. At the same time, it is equal to half times of base times its perpendicular height of 4 sine theta plus half times of 5 times 4 cosine of theta. So we're going to multiply throughout by 2. So we end up with 12 sine theta, 20 cosine theta equals to 15. So all we need to do is just to rearrange to put the cosine in front. 20 cosine theta plus 12 sine theta, and that gives us 15. Shown. Now in general, when in paper 1 or in paper 2, when you are asked to show a coefficient times cosine theta plus another coefficient sine theta equals to another value, most likely it's got to do with the R formula. So even if you're unable to show part 2, you can still do part 3. Where we have the R value of square root 20 square plus 12 square. So that is root 544. Don't evaluate this yet, otherwise you will have to be rounding off. Then we also have tangent alpha equals to 12 over 20. So alpha is simply tangent inverse 12 over 20. So now we are ready to rewrite the equation. 20 cosine theta plus 12 sine theta. So this gives us root of 544. And cosine theta, since this is a plus, we expect a minus. Minus this value. So from our calculator, we get (30.964 degrees). So we round this off to 31 degrees. So that's done. 4 marks. And in part 4, find the value of theta. Now since the left hand side of 20 cosine theta plus 12 sine theta is 15, after we have rewritten it, this is still going to be equal to 15. So square root of 544 cosine theta minus, do not use 31.0, you can use either 30.964 or tangent inverse of 12 over 20 for the exact value, and this is 15. Then all we need to do is to make theta the subject. Cosine theta minus tangent inverse 12 over 20, 15 over root 544. So cosine inverse, we will end up with theta minus tangent inverse. So let's combine a few steps. Cosine inverse 15 root 544. Then we're going to be adding tangent inverse 12 over 20. So the result is 80.939 degrees, which rounded off it to be 80.9.